Hello everyone, welcome to Geometry, Chapter 8, Part 2, Trigonometry for you and me. So we're going to go ahead and go through this section of Chapter 8 right now, and let's take a look at what we're going to be learning today. We're going to go over trigonometric ratios and the angles of elevation and depression. Now, it doesn't seem like a lot, but as I looked through the chapter, I realized that there are a lot of different concepts that are going to be coming at you today, so I wanted to split it up into several different sections. So we're going to have more of Chapter 8 on Monday, but this is all we're doing today, and it's going to be a little bit difficult for some of you, I know, to grasp some of these concepts. It will seem like none of it makes any sense, but I promise you that it does. There's a video that I want you to watch first off, and I'm going to have it play right here, included in this video, so that you can get an idea of not what we're doing exactly, but maybe how you'll feel at the end of this lesson. And then we'll talk about it in just a second. Here you go.
Hey, wait a minute. You owe me back room rent.
Now, don't get excited. How much is it?
You owe me 13 weeks at $7 a week.
Tidy sum, isn't it? Pardon me just a minute.
Sure.
Lou. Here's $28.
$28?
Give him that old routine of ours, 7 into 28, 13 times.
Hey, give me the Crayola.
Oh, yeah. Here. Now, and do it right this time.
Hope it works.
Make it snappy.
Okay. Mr. Landlord,
Yeah?
what are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks at $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's got to be. Certainly it is, because Mr. Rabbit and I, that's $28. That's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
Do you happen to have any Crayola on there?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. 7 into 28 is going to come out 13.
That's your way.
That's my way, and it's got to come out right. Now, first, I put down a 7.
Right?
Now, I'm going to divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
As you say it is.
We ain't going to hurt that little 2, are we?
Of course you won't.
So we take the 2, open your hand,
Yes.
and I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
Once, I put the 1 over here, 1 over there. Now, we're going to carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm going to drop the 7 under there. Now, 7 from 8
Is 1.
is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? I would like to use that 2. Open it up. Give me that 2. You've had it long enough. I'm going to put that 2 right there. Now, 7 into 21.
3 times.
That's right. 7 into 28. 13. Good enough?
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to emulsify it?
No, not multiply. Multiply.
Emulsify.
Multiply.
All right. Multiply it.
7 times 13
It's
prove
28.
it. Go ahead.
Now, first, we got to put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3.
21.
21. 7 times 1.
7.
7. 7 and 1.
8.
And 2 to carry. 28. Wait this out.
Now, wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way, and that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
It's got to come out right. There's 1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6,
6.
7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6,
Wait a
9.
minute. Let me do the adding this time.
Good. Come out right.
Well,
A 3, a 6, a 9.
Just a minute. I will do the adding. Then there'll be no mistake.
Yeah?
All right? $28 even. All right?
Sure.
Now,
Go ahead. If you had it up, go ahead.
3, 6, 9, 12, 15, 18, 21.
22, 23, 24, 25, 26, 27, 28.
All right, guys. So you can see that's just a little bit of fun right there. If any of you can tell me what was going wrong in each of those problems with the division, the multiplication, and the addition problems, what he did wrong to get that wrong answer, and it is the wrong answer, even if it may have fooled you a couple of times in there with the steps. If you can explain to me what's wrong in each of those three answers, we'll get you some extra credit here for the test for Chapter 8. But let's move ahead. I wanted you to see that video because some of what we're doing today may make you feel like the landlord in this video. May make you feel like what we're doing doesn't make any sense. It's not quite the same kind of math that we're always doing. But remember that I'm always saying that geometry is like learning a new language. And today, while doing trigonometry, we're going to be delving into some more of that new language. Trust me, it's a bit abstract, but it makes sense. And there is some important concepts in here that you're going to take with you into different areas of math in the future, if you take more trig in the future. It's also just the idea of being able to understand categories and units so that we can understand things. But we'll get into that in just a little bit. So let's start out here. Understanding trigonometric ratios. The ratio of the length of two sides of a right triangle is called a trigonometric ratio. The three most common ratios are sine, cosine, and tangent, which are abbreviated SIN, COS, and TAN respectively. So how do we get these terms, these things that we have as our trigonometric ratios here? We have a different angle that we're looking at. Let's take this triangle, for example, STR. If we're looking at the angle R, how do we get the sine of R? Well, the sine of R equals, and here we have a ratio like we've been working with, but we're going to take the measurements of the leg opposite R, so that's over here. They've represented the sides with a lowercase letter similar to the opposite angles with a capital letter, so capital R for the angle, lowercase r for the side over here. So the leg opposite there, the angle R, over the hypotenuse. So we get little r over little t here, and that's what creates the ratio. Now once we have values for that, we can plug them in and be able to figure out what the sine of r is. Cosine, very similar, we're doing the same thing, but we're using different parts of the triangle here. Instead of the opposite, we're using the adjacent leg, which is going to be s over here. So using the hypotenuse in the denominator, which is t. And then for tangent, or tan r, we're using the opposite side over the adjacent side, this time not using the hypotenuse at all. So here's what you need to understand. One little trick to keep in mind: if we have the opposite side represented, if we have the value of the opposite side is always going to go in the numerator. If we do not have the opposite side, then we can put the adjacent side in the numerator here. If we have the hypotenuse, that's always going to go in the denominator. If we do not have the hypotenuse, then we're going to have somewhere where we have the opposite and the adjacent, which is going to be tangent, and we're going to have opposite on top, adjacent on bottom. Depending on which sides we have is going to determine whether we're dealing with sine, cosine, or tangent. If we have the opposite side and the hypotenuse, well, then we're in the sine territory. If we have adjacent and hypotenuse, then we have cosine. If we have no hypotenuse, but we have the opposite side and the adjacent side, then we're in tangent territory. So these are the basic ratios to set that up for a problem here. But let's take a look at the example that they give us here. It says find the sine of A, cosine A, and tangent A. Express each ratio as a fraction and as a decimal to the nearest hundredth. Alright, so this is what we're doing here. It says for sine A, we start with our angle A here. We take a look at the opposite leg, the opposite side there, which is going to be BC, over the hypotenuse, which is BA. So that is 5, which is the value of BC, over 13, which is the value of the hypotenuse. So, and if you pump that into your calculator, you end up with approximately 0.38 or 0.38. And that's going to be the value that we use. Most of the time we're going to leave it in fraction form, but they want you to be able to do this because there are a few problems that we're actually going to use this on in just a second, dealing with a different portion of trigonometry. So let's then take a look at cosine and tangent. Again, we're doing the exact same thing, but this time instead of the opposite side for cosine, we're doing the adjacent leg. So instead we have 12 over the hypotenuse 13 into the calculator, and you get the answer 0.92, or approximately 0.92 once we've rounded. And the tangent of A, starting again with A, we don't use the hypotenuse for tangent, instead we use the opposite side, opposite leg over the adjacent leg. So we get 5 over 12, or approximately 0.42. Okay, always refer back to this slide here. You're going to want to come back to this section of the video, so maybe take a little look at the minutes and seconds here. You're going to want to look back at this or find a similar form that will show you what sine, cosine, and tangent are: opposite leg over hypotenuse, adjacent leg over hypotenuse, opposite leg over adjacent leg. If you can keep these in mind, keep these in front of you to always look back at what we're looking at here, you'll be able to then figure out each of the problems that we're going to do. So let's move forward with our first practice problem here. Okay, so I put 3 practice problems here on this page for you. We're going to do 3 of them because we're doing a little bit more than the last video. But like I said, I have cut this lesson a little bit short, so it's not the same number of problems as before, but I want you guys to get some practice here. If you want to go ahead and answer these on your own before we go over the answer, please pause the video now and work it out on your own. All right, guys, so let's take a look at what we've got here. For the sine of J, we are just using the opposite over the hypotenuse. So we've got 12 over 20. Simple enough, right? We didn't have to do any math for this. All we have to do is we have to look at what we're given. So we're not looking for any variables this time. We're just identifying what we have. So the sine of J for number 1 is 12 over 20. And I'm not going to ask you to get the decimal at this point. If you pump it into your calculator, you can write out the decimal yourself. Let's take a look at problem number 2. Problem number 2, again, we're going to get the opposite over the hypotenuse. So the opposite in problem number 2, we're doing the cosine first. So the cosine of number 1 is going to be the adjacent over the hypotenuse. So the adjacent is 16 over 20. So then we'll take a look at the tangent for problem number 1. Tangent for problem number 1 is opposite over adjacent, which is 12 over 16. All right, now let's take a look at problem number 2. All right, problem number 2, again, identifying the sine, we have opposite over hypotenuse, which is 24 over 40. For cosine, we have adjacent over hypotenuse, which is 32 over 40. And then for tangent, we have opposite over adjacent, which is 24 over 32. Problem number 3 is going to be a little bit different here. We've got some square roots in our problem, so we're still not doing the math actually though. We're still just identifying stuff with these problems. So these shouldn't take too long to get through. Again, we're just going to take a look at sine for problem number 3. Opposite over hypotenuse would be 36 over 24 square root of 3. Cosine of J is going to be 12 square root of 3 over 24 square root of 3. And tangent is going to be 36 over 12 square root of 3, opposite over adjacent. All right, fairly simple enough. If you follow these formulas, if you continue to just follow what's written down here, you can identify those easily enough. Next, we're going to be actually trying to find some of these. I think what we're doing next is inverse ratios. So let's take a look at that. We're going to be finding the measurement of the angles then. So using inverse trigonometric ratios, and you can use your calculator using the sine, cosine, and tangent to find the measure of the angle called the inverse of the trigonometric ratio. So what we have here is we're given two sides. We know that we're dealing with a right triangle here. So we've got to actually find the measurement of the angles. And here it's asking for the sine of t. The sine of t, which would be the opposite over the hypotenuse. So we know that the sine of t is represented by this ratio, 29/34. But we haven't actually gotten the measurement of the angle t yet. So sine of t is going to help us get the measurement of that angle, because when placing it in the calculator, we can use a little function on your scientific calculator, which if you don't have your own scientific calculator, TI-83 or something like that, most smartphones, when you turn them horizontally, can be used as a scientific calculator. Also, they have ones through browsers. So if you Google scientific calculator, you should be able to bring up a browser version of a scientific calculator, which you can put in sine -1 sine to the -1 power, and then this in parentheses, 29/34 in parentheses, and that will pump out the measurement of angle t once you get that in the calculator. Once you put it in the calculator, you'll come up with the measurement of this angle t here at 58.5 degrees. Okay, so let's use this here now. Start with problem number 1. We've got our opposite and adjacent legs. So since we have opposite and adjacent, if you remember back to the formulas that we looked at before, when you have opposite and adjacent, that means that you're dealing with a tangential problem as opposed to a sine or a cosine problem. We're dealing with tangents since we have opposite and adjacent. So we set up our ratio here as the tangent of t as the opposite and adjacent here. So we've got 14 square root of 3 over 34. So let's go ahead and actually pump that into the calculator. Here's a browser calculator that I found on calculator.net so that we can show you what's going into the calculator. And we should have here, which I did, I clicked on tangent, exponent -1, which is also called arctangent. They're representing it as arctan here. 14 square root of 3. When I put that into this type of calculator, it go ahead and puts the multiplication in there for me. Be very careful if you're using this one. I had some issues where it does try and do notation on its own. So if you mess up putting a parentheses in there, it tries to figure it out on its own, and it may pump out a wrong answer for you. So I'm still going to use this one because I think it's easy for me to represent to you what you're putting on your calculator, but be very careful if you end up using this one because it can cause some errors while you're putting it in there. So it was arctangent, or tangent to the -1st, 14 square root of 3 divided by or over 34. And we end up with 35.49. So if we round that up, it would be 35.5. So we end up with t, measurement of t, equaling 35.5 degrees. And we used tangent and then the inverse of tangent to get there. All right. And we ended up having to use our calculator. You're not going to want to do this by hand. I'm not going to teach you how to do it by hand. We're going to be putting it in the calculator. So once you get to this point, then you just pump this into the calculator and we get our answer. All right, let's try problem number 2 now. I think I skipped over the section where I normally say pause here if you want to work on these on your own. Hopefully, if you wanted to and you were able to, go ahead and do that before, and if not, you can do it now. But we're moving forward on to problem number 2. Again, now we've got our opposite side and our hypotenuse side this time. So what are we doing when we have opposite over hypotenuse? Well, we have sine. So the sine of t with opposite and hypotenuse is 7 over 18. The inverse of that, once we put that in the calculator, is going to be 22.9 degrees. And for problem number 3, we've got our adjacent leg and our hypotenuse here. So that's going to be cosine. Adjacent over hypotenuse is 34 over 87. And we get the inverse and we put that into the calculator, and that comes out to 67 degrees. All right, I want to talk a little bit about angles of elevation and depression. Many of the real world problems that involve looking up at an object can be described in terms of angles of elevation, which is the angle between the observer's line of sight and a horizontal line. When an observer is looking down, the angle of depression is the angle between the observer's line of sight and a horizontal line. So basically, and this has a lot to do with photography or graphic design, you're trying to determine the height of something that you're looking at, or the angle from the point of view right here. So it's right triangles again, but we're looking at various different points because this person right here may be 5 to 6 feet tall right there. So the line here is not actually on the ground, but it's elevated somewhat. It's the same length, the same distance, but this tree is actually going to be taller than what's represented by this triangle because we have to add this person's height. Likewise, with an angle of depression, if we're measuring this cliff face here, then we don't include the point from the point of view of the person looking down from there. We're actually just trying to get the cliff face itself. So we're looking at that. We're looking at elevation and depression. Here's the example for how we're going to do these types of problems. The angle of elevation from point A to the top of the cliff is 34 degrees. If point A is 1,000 feet from the base of the cliff, how high is the cliff? Well, this is where our sine, cosine, and tangent are going to come in handy, especially tangent during these types of problems. So we have our opposite and adjacent sides here, even though we're looking for the opposite side, we have the measurement of this angle. So instead of using the inverse is what we use when we're trying to find the measurement of the angle, but we can actually use just our trigonometric functions when we have the angle measurement. So if x is the height of the cliff, then tangent of 34, tangent of angle A, the measurement of angle A here, 34 degrees, equals opposite over adjacent. So we've got x over 1,000. So in order to then solve for x, we just multiply both sides by 1,000, and we get 1,000 times tangent 34 degrees equals x. Then you put that into your scientific calculator and you will come up with approximately 674.5, I think we're looking at feet here, feet. So the height of the cliff is 674.5 feet. All right, so let's take a look at a couple of problems here. Again, if you want to, I've gone ahead and left this here without animating it. Sorry about that, guys. I'm not going to go back and change it now, but if you want to go ahead and pause and try and work through the problem to get here, you've got 1, 2, and 3 to work through. Go ahead and pause now. All right, so we're dealing with problem number 1, which if I'm not mistaken, I've accidentally left the answer already here for you, but we'll go ahead and work through it anyways. So problem number 1, we have here our measurement of angle A. We have our adjacent side, and we're looking for our opposite side. So we can use tangent again, which is what we're going to be doing for these. We have tangent of 49 degrees equals opposite over adjacent. So our adjacent is 400 feet, so we're going to multiply both sides by 400, and we'll come up with x equals tangent of 49 degrees times 400. You put that into the calculator, and you should come up with the answer which just flew away. So I did animate it, but I did it backwards. Sorry about that, guys. All right, let's move on to problem number 2. Problem number 2 is actually going to be an inverse tangent problem. Why is that? Well, we're looking for the measurement of the angle this time. This time we're not given the measurement of this angle, so we can find the measurement of the angle by using the inverse of the tangent. So it says that find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So we're going to use now our inverse tangent with our opposite and our adjacent, put that into the calculator, getting 35 degrees as the answer for that angle. All right. Notice how what we do is we have to set up the problem properly, then enter it into the calculator without making any errors in entering it into the calculator, and we get our answer simply. So this lesson, we're doing a lot less paperwork. Hopefully you are. Hopefully you're doing a lot less paperwork with this one because you're using your calculators, but you're making sure to set up the problem properly. That's why I said make sure to refer back to our forms that that stated which ratio to use for sine, cosine, and tangent. Since we're just using tangent, it's going to be opposite and adjacent for each of these problems here. So I hope that's going well for you guys. We've got problem number 3 coming up next now. Here's the calculator, what it came out to when I put it in through the calculator, and we rounded up to 35 degrees. Alright guys, if you'll notice with problem number 3, we're doing an inverse tangent, and again we're trying to find the measurement of the angle. This time it's saying that we're finding the measurement of the angle from someone up here, and the 1,000 yards that they're giving us, it may look like it's labeling the hypotenuse or the length of this downward angle as 1,000 yards, but it's actually giving us this line here as the 1,000-yard line, which is equivalent to this line down here. And the 208, we could move over to this side. Notice that we've got parallel lines here and we've got a transversal. So this angle measurement right in this section is actually equal to this angle down here. So if we then realize that, we can use our problem here for opposite and adjacent to try and set that up. So our opposite side then is equal to 208 and our adjacent is equal to 1,000. So if we set that up to put it in the calculator, we have the inverse tangent of 208 over 1,000, which rounds up to 12 degrees again once we put that in the calculator. So that's problem number 3, guys. Let's go ahead and move on. All right, so now this is the one that I'm sure will be a little bit of a head scratcher for some of you. This is 2 angles of elevation and depression. So we're looking at the idea that there are 2 measurements that are being made. Now it's the same person, it could be 2 people, but in all the problems we're dealing with, I think we're dealing with one person that stands at a certain point looking up at the top of a building or the top of a cliff. Now because of where they're standing, they create a certain measurement of an angle. The top of the building, the height of the building doesn't change, but what changes is how far away from the building they are and the measurement of the angle from where they're standing, because they're standing at one point here, they have one angle and one length of distance between them and the building. Then they move away 20 feet. Now, because of how far away they've moved, the angle has changed and the length of distance between them and the building has changed. So we can use those measurements then to try and find out the x, the height of the building here, and we're going to include their height to try and determine the height of the building. We have x here, but x only determines from their line of sight height up to the top of the building. Just like with this, we have 20 feet here, but that only comes up to this point C, and from C to B we have y here. So here we say angles of elevation and depression are 2 different objects can be used to estimate distance between those objects. The angles from two different positions of observation to the same object can be used to estimate the height of the object. To estimate the height of a garage, Jason sights the top of the garage at 42-degree angle elevation, then steps back 20 feet and sights the top at a 10-degree angle. If Jason is 6 feet tall, how tall is the garage to the nearest foot? So they're going to break it down into our two different triangles here. We've got our triangle ABC, which is the smaller triangle right here, and triangle ABD, the larger triangles. They're both right triangles. We can determine that AB equals X and CB equals Y. They're just labeling those for us so that we can use the variables to find out their measurement. And DB is Y plus 20 feet, because we're told in the problem that he was standing at a certain distance away, which we don't know, which is Y, but then he moved 20 feet back. So the full length is 20 plus Y, or Y plus 20. So then we use ABC, using the opposite and adjacent sides. We have tangent of 42 degrees equals X over Y. Well, if we want to then isolate the variable X, we then multiply both sides by Y, and we have Y tangent 42 degrees equals X. Okay, I understand we haven't actually done anything with the problem. We haven't done any math. We haven't clarified what that is, but there's a very specific reason why we're isolating the variable X, because we're going to do some substitutions later. And you're going to see once we have different values for X, we can then understand more about X and be able to solve for it. So let's keep working here at triangle ABD. We're saying that the tangent of 10 degrees equals our opposite X over, now that's the full length here of the adjacent side, which is Y plus 20. So tangent 10 degrees equals X over Y plus 20. Now that can be rewritten by multiplying both sides by Y plus 20. We simplify it a little bit so that we have Y plus 20 tangent 10 degrees equals X. Again, we are isolating variable X here so that we get everything on this side of the equation all together and X by itself. We've done that to both of our triangles now and realize that we have two different series of variables that then add up to X or equate X. So we can substitute our value for X from ABD in an equation for ABC and then solve for Y. Okay, now at this point, to some of you, I'm sure I'm sounding like that Abbott and Costello video that I showed you at the beginning, where I'm trying to it sounds like I'm trying to trick you into not getting to pay the rent. But really, this does make sense. I understand if it may take a couple of times going through it, but this is going to make sense at the end. We're taking just categories of things that equal X, and we're putting them together so that we can then solve for it. So if we say that Y tangent 42, which was X we got over here, equals Y plus 20 tangent 10, which is over here, we're just saying that X equals X, but we've set them equal to each other now, and we're going to solve for Y. So we distribute our tangent 10 degrees into our parentheses here, so that we bring this down. Y tangent 42 degrees equals Y tangent 10 degrees plus 20 tangent 10 degrees. Notice we've got our Y from over here coming down. We've got our 20 from over here coming down. We've distributed the tangent 10 degrees in, but because we don't have any actual values for any of these, nothing is actually changing numerically, but we keep the same categories. We still have our Y. We're still multiplying it by tangent 10 degrees. We still have our 20. That's brought down, and we're multiplying it by tangent 10 degrees. Okay? Don't let me lose you here, because we're now saying, okay, we have an addition here. We're going to now subtract it from both sides of the equation, so that we have Y tangent 42 degrees minus Y tangent 10 degrees equals what we're left over is the 20 tangent 10 degrees here. All right, okay, so next step, we then realize that we have a y in each of these pieces of our equation on this side, the left side, that we can take the y out of both of those and end up with y, parentheses, tangent 42 degrees minus tangent 10 degrees, close parentheses, equals 20 tangent 10 degrees. I know it seems crazy. It seems like we're not doing anything. We're just shifting letters and numbers around, and it's not really solving anything, but we're almost there, guys. We really are. Because now that we have y set outside of this parentheses, we can take these parentheses and we can then divide both sides by it. So we now have y by itself. Y equals 20 tangent 10 degrees over tangent 42 degrees minus tangent 10 degrees. And amazingly, oddly enough, if you put this portion here into a scientific calculator, 20 tangent 10 degrees divided by tangent 42 degrees minus tangent 10 degrees, it will pump out the number 4.87 once we round up. Keep in mind, you have to keep the parentheses right when you put this in. When you put this in, you don't want it separating out the 20 and the tangent 10 or these numbers down here. You want the parentheses on top divided by parentheses tangent 42 degrees minus tangent 10 degrees, close parentheses. Then your calculator will pump out this answer. Seems odd, I know. I have not just convinced you that the answer is 28. It's not the Abbott and Costello video, I promise you it's not. But we're not quite done yet, because then if y is equal to or approximately equal to, which is what the wavy lines here means, 4.87, then x then equals 4.87 tangent 42. Well, where did that come from? How did we get that? Well, we had it up here. X equals y tangent 42 degrees. And if y equals 4.87, then we just replace the y, substitute the y with 4.87 tangent 42 degrees. Put this now into your scientific calculator, 4.87 tangent 42 degrees, and you'll come up with about 4.4 feet. Then you add Jason's height to that of 6 feet, and the garage is about 4.4 plus 6, or 10.4 feet tall. If we round it down, we can say the garage is 10 feet tall. If we round it up, which we shouldn't because we haven't passed the 0.5 mark here, we'd say 11, but it's approximately 10.4 feet tall. So we've gotten real numbers from what looked like a bunch of nonsense. What looked like something shouldn't have worked ended up working. And it's not a trick. It's not an Abbott and Costello joke. It's not something that doesn't really work out. I promise you the math works out here. We are depending a lot on our scientific calculator to get that answer for us. But these rules hold out. And so let's go ahead and depend on those scientific calculators for a few practice problems here. Actually, just one practice problem. I've gone ahead and edited some others out just for time's sake, and just because I think these do take a little bit of time. I want you to just work on this one here, and if you want to work on it on your own, pause the video now. Okay, let's take a look then at the problem. It says that Sarah stands on the ground and sights the top of the steep cliff at 60-degree angle of elevation. She then steps back 50 meters and sights the top of the steep cliff at a 30-degree angle. If Sarah is 1.8 meters tall, how tall is a steep cliff to the nearest meter? Okay, so we've got our two triangles here. We've got 60 degrees, we've got x and y. We've got 30 degrees, we've got x and 50 plus y. So let's go ahead and set up our problem. The first thing we're going to do is we've got tangent of 60 equals opposite over adjacent equals x over y. So we're setting that up for the first triangle. Then we solve for x, meaning that x equals y tangent 60 degrees. These are the same steps that we just did with the example problem, but we're doing it now with this problem. We're still in this first triangle. We found out that this is the value of x. So we're going to move now to our second triangle with a 30-degree angle here. The tangent of 30 degrees equals x over y plus 50. Okay? So then, in order to solve for x there, we're going to multiply both sides by y plus 50. Cancels out on this side, we get x alone, and the other side ends up being y plus 50 times tangent 30 degrees. All right, let's go ahead and keep those there. We had x equals y tangent of 60, and we also had x equals y plus 50 times tangent of 30. Those are our two values for x that we found, so we're going to bring them over and continue our problem now. We set them equal to each other so that we have y tangent of 60 degrees equals y plus 50 tangent 30 degrees. Then we're going to go ahead and distribute the the tangent 30 degrees into the y plus 50 so that we end up with y tangent 60 degrees equals y tangent 30 degrees plus 50 tangent 30 degrees. Notice we still have our y down here. Tangent 30 came in this direction. We still have our 50. We brought it down here. Tangent 30 times that. Okay? So then we go ahead and we subtract what we're adding here from both sides so that on this side we get y tangent 60 degrees minus y tangent 30 degrees equals 50 tangent 30 degrees. All right, let's continue on with that problem here. We're going to have y tangent 60 degrees minus y tangent 30 degrees equals 50 tangent 30 degrees. But then we can isolate out that y so that we have y parentheses tangent 60 minus tangent 30 equals 50 tangent 30. Then we get y by itself on one side of the equation by dividing both sides, and we end up with y equals 50 tangent 30 degrees divided by tangent 60 degrees minus tangent 30 degrees. All right, again, guys, I know it seems like we're just shifting around maybe Greek alphabet, maybe something weird that in Latin that you've never learned in one of your classes. I think a couple of you have actually taken Latin, so that doesn't quite work out. But it may seem like we're dealing with a foreign language here, and to a certain extent we are. We're dealing with terms that have specific meaning in the language of math, and we're moving them around based on certain rules, but there is meaning behind it. And your scientific calculator is going to parse it out for you. It's almost like if we have any Star Trek fans in our class here, Star Trek has something called a universal translator. They'll take any language, pump it in there, and it'll come out in English so that everyone can understand it. Our calculator is going to take our math language and pump it out into a math that you understand. So put into our calculator here 50 tangent 30 degrees divided by tangent 60 minus tangent 30. You don't have to put in degrees, but in the scientific calculator it will ask you whether or not you're going to be using it in degree mode, and you need to keep it in degree mode, otherwise it will come out with the wrong answer. So let's go ahead and take a look here at what we got. Here's my handy dandy Google calculator that I found. Placing it in there, once I've put it into that calculator, it popped out the number 25. Very nice number, very simple number, way simpler than some of the other numbers we're looking at. So 25, y equals 25. Great, excellent. So then we go ahead and we take what we had gotten earlier and we replace it in there. So we had y tangent 60 as one of our values for x, So x equals y tangent 60, substituting in 25, x equals 25 tangent 60. So then we take this and we put it back into our calculator. We erase the problem that we just did, keeping track of what we had done before, but we erase it by clicking the clear button. We put in 25 tangent 60, and that should come out with 43.30, but we're not done yet because we still have the height of Sarah, 1.8 meters tall. We add that together to get an x of 45 meters. So the height of the cliff in total is 45 meters tall. All right. These have been the problems, guys. This has been it. This is all we're doing for today. When we come back, we're going to have some more trigonometry to go into, some more things that I feel are going to be a little bit mind-bending. I didn't want to throw too much at you today, so I'm not going to go into the rest of the chapter at this point. Make sure that you're doing your homework. I hope that you all are staying healthy. I hope that you all are doing well. I know that I have a lot of tests that you guys have turned in and stuff from other classes that I need to get back to you. My plan is to get back to you and email you back on some of those tomorrow. So hopefully we can talk and we can get some of those things done. Thanks for showing up and for listening to the lecture today, guys. I hope that you're having a good day and that your families are well and that you're well as also.
You're still here? It's over. Go home. Go.